Hello friends, welcome to Suresh Agarwal's Mathematics Shortcuts. So in this video, I am going to continue the same chapter of pair of linear equations in two variables, and a very important video because these equations are not actually linear equations, and when we make a small adjustment in the equation or a small simplification or a small substitution for that matter, it becomes linear, and these are called the equations reducible to linear form. A very important concept for all the competitive exams and for class 9th and 10th students, especially for class 10th board exams. The topic is really important. So watch the entire video. You are going to learn different models of questions which can be asked in the board exam. Before taking up the questions, let me tell you about the CBSE practice worksheets which we have very recently launched, and these practice worksheets they carry unlimited validity, and these are specially meant for class 6 to class 10 students. There are two ways you can get these CBSE practice worksheets. One is downloading our app, that is Learning Loop. This app is available on the Google Play Store, and the link of the app is given here in the description box below. Or you can send me a message on WhatsApp 9896369963. That's the WhatsApp number on which you can send me a message, and I'll tell you the details how you get a copy of those CBSE practice worksheets, which will help you in concept-wise preparation and a very comprehensive preparation for any type of exam which you may be appearing in. There are videos also for better understanding of the topics. So let's take up the questions in hand now. The first question, here you can see there are two variables u and v, and these two variables are multiplied on the right hand side. So this makes it non-linear. Why? Because when two variables are multiplied together, the degree of the term becomes 2, and therefore it is non-linear. Now when you have to solve such an equation, you can do it in two ways. One is the way in which the teachers will ask you to do, and the other one is the direct method. So I'll tell you both. This is the second equation, and now we will try and use the traditional approach first. The teachers are going to ask you to divide this equation throughout by this term uv. Okay, so you will get v in the denominator here and u in the denominator here, and so the equation gets converted to linear form. That is one way of doing it, and the other way is going for the elimination by equating coefficients directly. How do you do that? Here you have 2u and here you have u. So if you multiply the second equation by 2, you will directly convert it into the equations having the same coefficient. So let's do it directly. 2u plus v equals 7/3 of uv, that is the first equation, and the second equation, multiply this by 2, so you get 2u plus 6v equals 22/3 uv. Right? Now if I subtract these two equations, the 2u is going to get cancelled, so we have to change the sign of the second equation here like this. So 2u gets cancelled, and we have v minus 6v, which is minus 5v, and 7/3 minus 22/3. Now you got to do that subtraction. 7 minus 22 is minus 15, so minus 15/3, that is minus 5 uv. So I added and subtracted the like terms one below the other, and so I can see some common factors getting cancelled. I can see the negative getting cancelled, the 5 getting cancelled. So v equal to uv, and v also gets cancelled, thereby giving you u equal to 1. So once you get the value of one of the variables, finding the other variable is just a formality. You just have to put this value in one of these equations. So I'll pick up the first equation. 2u, u is 1, plus v equals 7/3 uv, u is 1 and v, right? So I put v u equal to 1 in the first equation. That gives me 2 plus v equals 7 by 3 v. And so 2 equals 7 by 3 v minus v, which gives 2 equals 4 by 3 v. And when you cross multiply, 4v equals 6. So v equals 6 upon 4, which is 3 upon 2. And that gives us the solution u equals 1 and v equals 3 by 2. Now this is the direct method of solving this pair of linear equations. Not exactly linear equations, they are non-linear equations, but the method of elimination by equating coefficients still applies to solve this particular question. Another such type of question is the question when x and y are in the denominators. So here you can see x and y in the denominators of the first equation and likewise in the second equation. Even here, most of the teachers are going to tell you to do 1 by x as a and 1 by y as b. Now this is the traditional thing what teachers ask you to do, and that's perfect because they want you to reduce this into linear form and then apply the method of equating the coefficients. But even if you don't convert it into linear form and then apply the method of equating coefficients directly, it still works. I'll show you how. So in the solution, I am going to write these two equations one below the other like this, and I will try to equate the coefficients without converting them to linear form. So what is the LCM of 8 and 6? It is 24. Or you can take LCM of 3 and 5, that is 15. So either convert the coefficients of y as 15 or the coefficients of x as 24. Let's do for x. So this is 3 times because this will get converted to 24, and this is 4 times, so 6 times 4 is 24 again. So the equations now become 24 upon x minus 3, that is 9. 9 upon y equals 15, and the other one is 24 upon x minus 20 upon y equals minus 8. And now add or subtract. So you need to decide that. I told you in my previous video, when the sign is same, you need to subtract them. So when you subtract, the sign changes, minus, plus, plus, and so 24 upon x gets cancelled. Minus 9 and plus 20 is 11, right? So 11 upon y equals 15 plus 8 is 23, and therefore you have the answer for this question. Just by cross multiplying this, you can find the answer. So here you get 23y equals 11 and y equals 11 upon 23, which gives you the value of y for this particular equation. Now let's put this value of y in one of the equations. Let's pick up the second equation. 6 upon x minus 5 upon y, so 5 upon, the value of y is 11 upon 23 equals minus 2, and so 6 upon x minus, so 11 upon 23 is going to get flipped, right, when I take it to the numerator. So 23 into 5 is 115 upon 11 equals minus 2. So 6 upon x is 115 upon 11 minus 2, which gives me 115 minus 22 upon 11. So 6 upon x is, so when you subtract these, you get 93 upon 11, and 6, I think 3 is a common factor, so 3 2 times and 3 31 times. That gives 31x equals 22, and the value of x comes out to be 22 upon 31. That is the answer for the question. So x is 22 upon 31 and y is 11 upon 23. Next question, very similar to this question. Now you can apply the method of equating coefficients directly here. So the teachers are not going to tell you to apply the method directly. They'll ask you to do 1 upon x plus 1 equal to a and 1 upon y minus 1 equal to b, and that still works because you will have 5a minus 2b equal to half and 10a plus 2b equal to 5 by 2, and then you can find the values of a and b and put it here to get the values of x and y. Okay, but again, I insist that you can still apply the method of elimination directly without having to put a and b. So let's write this equation here: 10 upon x plus 1 plus 2 upon y minus 1 equals 5 by 2. Now this is the pair of equations which I have to tackle now. And you can see this term is exactly the same, and this is minus, this is plus, so this gets cancelled directly. And 5 plus 10 is 15, so 15 upon x plus 1 will be equal to 1 by 2 plus 5 by 2, which is 6 by 2, and that is 3. Pretty easy from here, right? Just cross multiply this, you will get 3x equals 12 and x equals 4. See, direct answer, no substitutions required. Now I can put x equal to 4 in any of these equations, so I'll use this equation this time. 10 upon x is 4, so 4 plus 1 5, plus 2 upon y minus 1 equals 5 upon 2. This is 2 plus 2 upon y minus 1 equals, so 5 by 2, and so 2 upon y minus 1 equals 5 by 2 is 2.5, right? And 2.5 minus 2 is 0.5, that is 1 by 2. Cross multiply, y minus 1 is 4, and so y equals 5, and so your answer is x is 4 and y is 5. Likewise, you can go on and find so many different types of questions. See here again one of those questions in which substitution may be required, but you can solve it directly here also. So let's write this equation under this: 3 upon x minus 2 upon y equals 4 upon xy, and now this pair of linear equations is to be solved. So I can see a 4 here and a 2 here, so if I multiply this by 2, this will also become 4. So the first equation, 5 upon x plus 4 upon y equals 14 upon xy, is not going to change. The second one will become 6 upon x minus 4 upon y equals 8 upon xy, and so this gets cancelled. Now because I am adding them, 5 plus 6 is 11, so 11 upon x equals 14 plus 8 is 22, so 22 upon xy. Now you can see a common factor getting cancelled between the numerators and between the denominators. X gets cancelled, 11 gets cancelled, and so if you cross multiply you get y equal to 2 as the first part of your answer. Now put y equal to 2 anywhere. I can use the first equation: 3 upon x minus 2 upon y, 2 upon y. What is y? Y is 2 again, equals 4 upon xy. So 4 upon x is 2, y is 2, so this becomes 2x. So let's simplify this: 3 upon x minus 1 equals 2 upon x, and so 3 upon x minus 2 upon x is 1, gives me 1 by x as 1, and so x is 1. So the answer, x equal to 1 and y equal to 2. So you can see so many different types of questions are there when it comes to equations reducible to linear form, but all of them can be solved using the elimination by equating coefficients, and that's what smart students do. So friends, if you like this video, do share it with all your friends. Don't forget to subscribe the channel and stay updated with all the uploads on the channel by clicking the bell shaped icon also. Thanks for watching this video. Look for more such amazing parts of the chapter of the pair of linear equations in two variables. All the best for your practice.